This is the Bambu Lab H2S laser combo. It's like the H2D, just without that second nozzle. That means it can use the full build area of the bed, and as a bonus, the total build volume is slightly larger overall than that of the H2D as well. Plus, of course, as the laser combo, this thing has a laser cutting and engraving module and a digital cutting module, and we'll get into more detail in like 5 seconds. Go! Hello 3D printing friends and welcome back. Okay, so today we're looking at the Bambu Lab H2S laser combo. Bambu Lab sent this over free of charge, so we could all get a look at it. I'll cover the specs and features, and we'll see a few projects I did with it, and then I'll let you know what I think of it. Feel free to use the video's chapter markers to jump to what interests you the most. So, onward to the specs and features. The H2S laser combo has 3 main functions. First, it's a 3D printer with a build volume of 340 millimeters on the x-axis, 320 millimeters on the y-axis, and 340 millimeters on the z-axis. It comes with a 0.4 millimeter hardened steel nozzle that can get up to 350 degrees Celsius, and Bambu Lab sells other nozzle sizes to suit your needs. The bed can get up to 120 degrees Celsius, and it has a textured PEI flex plate for easy removal of finished prints. The build chamber features active temperature management and active heating up to 65 degrees Celsius, so you can print those higher-end materials that need heated enclosures. Part of that active temperature management includes keeping the chamber temperature closer to room temperature for materials like PLA. With an air intake vent at the front and an exhaust vent at the back, you shouldn't have to open the printer's front door when printing lower temperature materials. The chamber also has air filtration, including a HEPA filter and an activated carbon filter to handle particulates and VOCs released during the printing process. The unit Bambu Lab sent also included the AMS2 Pro, which is faster than the original AMS units, has more durable filament inlets, and can also act as a filament dryer. While it's capable of drying the filament and has the option to spin the spools while doing it, you can also turn off the spin feature. I thought maybe that meant I could have the AMS2 Pro actively drying filament during a print, but no. I set it to dry the filament without spinning the spools, but as soon as I started a print, the drying feature stopped. The printer has a variety of cameras and sensors on board, including a filament runout sensor so it can let you know when you need to run out and get more. Actually, you could load all 4 slots of the AMS with the same color of filament and tell the printer to start using the next available spool when the current one runs out. And even if you don't, the printer will pause when it runs out and let you know. That actually happened to me during one of the bigger prints I did, and I'll talk about it when I get to the projects in a few minutes. The last few things to cover are the 5-inch color touchscreen, which has what I consider one of the better user interfaces for a 3D printer, and it's one I've seen copied on several other printers lately. It's got 8 gigabytes of onboard storage, but there's also a USB port that you can plug a flash drive into. In fact, the flash drive is required if you want the printer to create time-lapse videos of your prints. And last, the printer's got Wi-Fi on board, but no Ethernet. Bambu Lab still only has Ethernet ports on their Pro and Engineering machines, notably the H2D Pro and the X1E. This version of the H2S, the laser combo, is also a laser cutter and engraver. It includes a 10-watt diode laser module operating at a wavelength of 455 nanometers. You'll notice that on the laser combo version of the printer, the top glass is black instead of clear. You'll also notice that the front door is green tinted plexiglass, and both of these features are designed to keep laser light inside the printer and out of your eyeballs. Yes, plexiglass with a capital P and 1 S is a registered trademark, and this is probably plexiglass with a lowercase p and 2 S's. You know what I mean. Anyway, mounting the laser module is as simple as unsnapping the front cover on the tool head, removing the spinner, and latching the laser module onto the front. Connect the laser's cable to the port on the top of the tool head and connect the air assist hose. Yes, conveniently, the H2S has a built-in air assist pump to blow the smoke away from the material you're cutting or engraving to help keep those cuts and engravings looking sharp. And last, remove the flex plate from the printer's bed and put the laser bed in its place. Now it may sound like a lot of steps, but it's actually pretty quick to do. After you get the laser module installed, the printer uses the touchscreen to walk you through a quick calibration reminding you to make sure you've got the laser's latch latched and the air assist hose connected. Then it uses the various cameras and sensors to make sure the laser bed is installed properly and stuff like that. That takes another couple of minutes, and it's something the printer runs through every time you install the laser module. At first, that seemed like a pain, but then after giving it a bit of thought, it makes sense for the printer to do its best to ensure everything is set up correctly prior to vaporizing things with high-intensity light. Oh, and importantly, the laser combo includes an emergency stop button that mounts at the bottom right side of the printer. If you run into any sort of issue with the printer, particularly when it's laser cutting or engraving, you can smack that button to completely cut power to the printer. Another good safety tip with any laser cutter or engraver is to keep a small fire extinguisher nearby in case of a fire. One other thing you need to be very aware of with any laser cutter or engraver is that they can generate a ton of smoke and odor, blasting away material from the things you want blasted as they cut and engrave. To accommodate that, the H2S has an exhaust fan to pull the smoke and fumes out of the chamber, and there's an exhaust hose that connects to the back of the printer. Now, that exhaust hose has to go somewhere, and Bambu Lab expects you to set up the H2S near a window so you can open that window and hang the exhaust hose outside. If your 3D printer area is not in a place where you have the ability to easily vent the smoke outside, Bambu Lab sells a smoke purifier unit. I haven't tested the one from Bambu Lab, so I can't comment on how well it performs. But it sort of looks like it still wants to vent the filtered air somewhere else because it's got an output port that another hose could attach to. The last thing that the H2S laser combo can do is digital cutting, so it's like a Cricut machine. Honestly, I was actually quite hesitant to try this feature at all. You ever feel that if you don't think you're going to be instantly successful at something, you just don't even want to try? That happens to me sometimes, and it happened with this digital cutting feature. It just seemed like it was going to be way outside what I was used to and comfortable with. But I did it anyway, because I wanted to at least get a taste of what could be done with it. Like the laser module, the cutter module plugs into the top of the tool head and latches onto the front of it. And once it's there, the printer automatically detects it. And so after reading through a few of the tutorials, I used the Print Then Cut feature. This lets you print things, that is 2D print on a paper printer, and then put that paper on the cutting mat and let the H2S cut them out. If you think that feature sounds perfect for making your own custom stickers, well, stick around, because in the projects part of the video that's coming up next, I'll show you what I made. Yay, it's project time! Let's take a look at a couple of the projects that I made with the H2S. First, I wanted a box to hold the accessories that came with the laser combo, like the laser module and the cutter module, so I found this one by Plastic 3D. Since I wanted to be able to locate this quickly and easily, I printed it in some orange PLA. I don't have a lot of orange boxes here in the studio, so that should work out great. The box consists of 3 parts. There's the main body of the box, the lid, and an insert with cutouts for the various accessories. The main part takes about 6 hours, the lid takes about 4 hours, and the insert takes about 5 hours. So this is 15 hours worth of printing to get this done. Actually, for me, it was more like 20 hours because the insert didn't properly fit the laser module, so I had to throw the model into Tinkercad to make an adjustment. And while I was in there, I added some walls around this little area in the middle to hold all the little plastic bags that came in the tools package. So another 5 hours to reprint the insert. But once all the pieces were done, and I added some M3 screws and nuts to complete the hinges, I was pretty happy with the results. As far as print quality, to me it all looks really good. Smoothly stacked layers, smooth surface finish, and all the parts stayed stuck to the bed throughout the print. I also made this cool desktop drawer unit called Structura by Riley Designs. This is a hybrid project with some of the parts 3D printed and some of them laser cut from 3mm plywood. The body is printed in Polymaker's Polyterra Sapphire Blue PLA, and this part of it is an 11-hour print. It takes about 750 grams of filament, so that's like 3/4 of a spool. I had an older spool of this sitting around and it looked like it was mostly full. I should have waited before I started printing though because I ran out about 10 hours in and I didn't have any more of it in the house. So I had to place a quick order on Amazon, and fortunately, same-day delivery was available, but it did take until the end of the day to show up. The H2S took it all in stride though. It stopped when the filament ran out, alerted me to the issue, and it kept the bed hot for the duration so the print would stay stuck. When I got the new spool loaded, the print had been paused for probably a good 14 hours. Interestingly, the older spool had some slight color variations to it, while the new spool's color was much more consistent. Given the design, I can almost imagine that the variations are kind of like wood grain, so it kind of makes it look like the drawer body is covered in a wood veneer that was dyed blue. Anyway, both the small drawers and the large drawer get their sides printed, and that takes an additional 9 hours. But the drawer bottoms are laser cut plywood, the drawer fronts too. At just 20 minutes to laser cut all the parts, those are super quick compared to the 3D printed parts. The last of the 3D printed parts are the drawer pulls, and I did those in a gold silk PLA. To make them look really nice, I printed them at a 0.16mm layer height and slowed the outer wall speed down to 30 millimeters per second. That gave them a nice shine, but it did take another hour and a half to print them. In the end, the result is really nice. I may put a clear finish on the drawer faces though, just to give them a little more depth. Now, this is a nice laser cut fidgety thing called Laser Cut Fidget Gears by NR Workshop. This only took like 8 minutes to cut and then another 10 minutes to assemble with wood glue. And it works pretty well. Spinning one gear causes the rest of them to spin. Plus it looks cool. One thing I ran into with this model and the laser bed on the H2S is that this had a lot of little parts that just fell down to the bottom of the laser bed when they were cut out. And at least one of these little circles ended up underneath another part that was being cut, so it got marked up a bit on one side when the laser cut through the material above it. Fortunately, that didn't affect the final outcome of this model, but it does highlight an issue you can run into when using the included slat pack material supports on the laser bed. Specifically, on a large sheet, the slats can't provide enough support for the parts that are being cut. You can even see that it happened on one of the projects Bambu Lab has on the page for their birch plywood. This is where Bambu Lab's optional grid panels would really have been handy, because those have much smaller gaps, and so it's less likely that parts can fall through. I also wanted to engrave some Slate drink coasters, and I wanted them to have a coffee theme. So I found some inspiration with a Google image search, and I put these together in my usual graphics program. The end result is pretty good, quality-wise, but getting the designs aligned on the coasters was another matter, and I'll get to that in a minute. Engraving the designs onto the slate was harder than it needed to be because the app didn't have a material profile for slate. So I ended up having to create my own. It took me a few minutes to do, but I feel like the software should already have known about slate. This is a super common material to use with a diode laser. Anyway, that aside, I want to get back to the design placement issue. The software uses the printer's bird's eye camera to take a picture of the objects on the laser bed, but that camera is at the front of the printer and it's only centered left to right. Since it isn't directly over the center of the bed, the software has to do some additional work to figure out the position of the items and where to actually cut or engrave so that your designs end up where you want them to. Unfortunately, the further away from the front of the printer an object is, the more likely it is that your design won't be exactly where the screen shows it's going to be once it's engraved on the object. And that's what happened with First I Drink the Coffee and I Don't Need an Inspirational Quote. Those two were toward the back of the laser bed, and even though I had the designs nicely centered on screen, they were definitely not centered when they were engraved. And to hold the coasters, I printed this nice looking coaster holder designed by Kyber Creations. I had to scale it up a little bit to accommodate the size of the slate coasters. If you're wanting to print it for your own 100mm slate coasters, the final scaling was 110mm on X and Y and 42mm on Z. That made it just big enough for the 4 coasters, and at that size, it took about an hour and a half to print. It came out really nice, and it's the perfect size for these. Then I printed this tiny Toothless dragon because it was a 4-color print. That let me use all 4 slots in the AMS. I loaded up black, white, red, and green PLA. And this little guy turned out really great. There are a few little strings around the wingtips, but that's it. Everything else about it is super clean. The surface finish is smooth and glossy, and the delineations between the colors is clean and sharp. Now, doing a multicolor print with a single nozzle printer is always going to generate purge waste. And here's how much purge waste the printer pooped when I printed the Dragon. It's about 58 grams of purge for a 17-gram print. It's crazy that the wasted filament is 3.4 times the amount of filament in the finished product. Now, I actually printed 2 of them because I knew my kiddo was going to want one and she wouldn't want to wait for me to finish the video before she could have it. But here's the thing. No matter whether I printed 1 or 2, the waste amount is still that same 58 grams of material. It's just that by printing 2 of them at the same time, now the purge waste is only 1.7 times the amount of an individual Dragon. So knowing that no matter how many I print at the same time, the waste amount doesn't go up, I could fill the build plate with them and print like 22 of them all at the same time. With 22 of them, I'd have 370-ish grams of finished product and still only have 58 total grams of waste, so the amount of waste per Dragon drops to 0.15 times the amount of the finished product. Of course, it would take over a day to print all 22 of them. So there are little tricks you can use here and there to make multicolor printing less wasteful. But this particular trick really only applies if you need more than 1 of a model. But still, this little guy came out so good. The penultimate project here is the Exagon phone stand by S. Matty. It's a simple design with a retro vibe, a little more 80s style. I printed this in black with a red stripe. It takes about 2 hours to print, and I liked it so much I printed it again, this time with a green stripe. The print quality on them is good, like really good, and it holds my caseless phone with no problem. For those of you who rock cases on their phones, there's also a version that accommodates the extra thickness on those, so you can enjoy this one as well. In fact, S. Matty has created a whole series of these, so they also accommodate charge cables, or even larger phones, or different surface textures, but I like the hexagons the best. The only thing I'd recommend doing is adding some tiny rubber feet to the bottom to prevent them from sliding around. The final project is a digital cutter project. With the H2S, there really isn't a lot of practice material included for the digital cutter, so I felt like I was kind of on my own. But I have full sheet adhesive shipping label paper, so I figured I at least had what I needed to make stickers. And after a few tries, I was able to get that working, so now I have some BV3D stickers. I also made a few of this other sticker because my kids saw this design and thought it was funny. The quality and accuracy of the sticker cutouts is pretty much spot on, which is even more impressive when you consider that the cutter's paths are sent to the H2S and the images are sent to my paper printer. Then I have to put the printed paper on the digital cutting sticky bed. The software adds registration marks that get printed on the paper to help the H2S align the cuts. I think digital cutting, like laser engraving, is part science and part art form. There are settings to be tweaked to get things just right. For instance, I set the H2S to cut through the sticker paper but not the backing, and then to move a little further out and cut through both the sticker paper and the backing. The idea was to have the stickers fully cut out, but then have the ability to easily peel the backing off. Unfortunately, the printer cut all the way through on both cuts. I think with a little more time and patience, I could get this dialed in and it would be perfect. Next, I want to touch on the software situation real quick. Bambu Lab didn't add the laser and the digital cutting stuff into Bambu Studio. Instead, they released an entirely separate application called Bambu Suite. So with the H2S and the H2D, you still use Bambu Studio to slice and print 3D models. But when you want to do laser stuff or use the cutting module, you'll do that in Bambu Suite. I don't know if all that will eventually be rolled into a single application, but for now, it's 2 different things. Now I want to go over what I like and don't like about the H2S laser combo, starting with what I like. First, it has the largest build volume of any Bambu Lab printer. Like the H2D, it has the LED status bar at the front of the bed. It has the ability to do more than just multicolor 3D printing. Laser cutting and engraving isn't all that new to me, but the digital cutter is, and it's interesting having all 3 in one machine. I feel like I should try to get out of my comfort zone more often, exploring other maker technologies and broadening my horizons. Using the laser to cut or engrave wood can generate a fair amount of smoke, and I was afraid this would result in the interior of the printer being coated in soot and smelling like a fireplace, but so far that hasn't happened. The quality of everything I've done with this printer has been really, really good. Print quality, on par with other Bambu Lab machines. Laser cutting, excellent with smooth, clean cuts. Engraving on slate came out great. Digital cutting, accurate cuts, though a tiny bit deep for the stickers I made. And when using the laser or digital cutter, the view from the interior camera is shown on the printer's screen. That's actually pretty handy. Now, here's where I think the H2S could use some improvement. That green laser safety plexiglass that the printer's front door is made from makes it harder to visually monitor a print. It's just harder to see through than the regular glass on the non-laser version of the printer. I get why it's needed, obviously, but it would be cool if there was an option to view the build chamber camera on the screen like it automatically does when lasering or digital cuttering. Multicolor purge waste is still an issue, but it's one that affects any multicolor single nozzle printer. On the AMS2 Pro, I don't know if there's a technical reason preventing it from being used as a filament dryer while actively printing, since the spool spinning feature can be turned off, but that would be a nice feature to have. The laser cutting and engraving feature requires that the printer be able to vent outside or requires a really good smoke and fume capture system. So the printer needs to be near a window or you'll need to shell out extra for the smoke purifier unit. The Bambu Suite app feels a little clunky and takes some getting used to, and I feel like it needs more material profiles for commonly used laser materials like slate coasters. So yes, that's the software and not the H2S itself, but it's part of the whole package and needs to be considered. So that's the Bambu Lab H2S laser combo. Thanks again to Bambu Lab for sending the H2S over. Thank you for watching, and big thanks to everyone who supports the channel, whether with channel memberships or by using the links in the description. If you liked this episode, give it a thumbs up and maybe subscribe so you don't miss new ones. Well, 3D printing friends, that's about all the time we have for this one, and now that we're at the end, let's go make something cool. It's a simple design with a retro vibe. Good Lord, Brian, do better.